So who is the audience for this class? Of course, first of all, gINT users, those folks who use gINT on daily basis or often in their professional lives to produce all kind of subsurface investigation reports. Then gINT power users, those are gINT users who use gINT at advanced level. Then gINT administrators or gINT managers, people who are responsible that everything works properly at their companies in regard to gINT and take care of standardization. And then finally, anyone who wonders about gINT and would like to learn more about it. So who was the source for questions? We tried to cover all the angles. We asked 4 questions across the board. Of course, we started with Bentley Technical Support Group, TSG, our first responders who receive the most questions and keep the users happy on daily basis. Bentley Professional Services, our elite unit that tackles customization for clients during that process, answers all kind of why this or why that questions. Bentley sales, technical and business evangelists who by introducing our software to users, making their professional lives easier, they get their share of questions as well. And then Bentley product management and development, the usual suspects, right? And then of course gINT power users and gINT administrators, managers, again like folks that have advanced questions and who push gINT's limits, and by that occasionally making product managers' life miserable. So let's get to questions and answers. As a presenter, I took a liberty to post first question. What is gINT? So why this question at all? Well, first of all, for those who wonder about gINT and hear for gINT for the first time, is simply to answer this question. And for those who know what gINT is, to expand on it, to see where gINT is going and how gINT developed over the years. So gINT is a database manager and reporting engine for subsurface exploration. It has many purposes. It is used for data storage, for data validation, for data queries, for data reporting, and for data sharing with other programs and applications, either Bentley programs or programs by other vendors. gINT can be used by anyone who investigates the subsurface or utilizes subsurface data. I like to divide gINT users to 2 groups. Primary users, those who use gINT as a standalone software, such as geotechnical engineers, environmental professionals, engineering geologists, and to a certain extent mining specialists. Basically all those professionals who perform subsurface exploration, collect the data, save the data, manage data, and generate all kind of reports related to their disciplines. The second group of users is subsurface data consumers. They don't necessarily know how to use gINT, but because gINT saves its data to a back-end database, such as Microsoft Access or Microsoft SQL Server, for example, this data is readily available for anyone who wants to reuse it, such as GIS analysts to display subsurface data on the map in various forms and shapes, civil engineers in road design and land development, structural engineers in foundation design, and subsurface data, of course, can be used in water resources and H&H design. So the whole concept of gINT is centralize subsurface data and then collaborate across the disciplines and throughout the project lifecycle. For engineers and professionals of different kinds, it is much more logical environment to search for data on the maps than going through the drawers, boxes, or chasing files and folders all over the network. And finally, we believe that gINT is most comprehensive software in this niche, and compared to many others, it is a superset. It is common misconception that gINT is a logging program. To be honest, gINT is a logging program, but it is much more. gINT has a comprehensive set of reporting tools of all kinds, way beyond just logs. So gINT is so flexible that it can provide functionality from just logging in form of gINT logs and all the way to the enterprise database management with comprehensive reporting, such as gINT Pro Plus, all with the same familiar interface. Question: what are gINT library, project, and data template? gINT library or GLB file, data template or GDT file, and project or GPJ file are three very important files in gINT, and they are crucial for understanding how gINT works. In gINT Pro Plus, data template and project converge. Let's start with a library or GLB file. The library file contains all your reports, symbols, drawing library drawings, library tables, lookup lists, and user system data. Only one library file can be in effect at a time. Even though you can have many libraries located anywhere on your system, it is highly recommended to use only one library company-wide. This enables easy and consistent gINT administration and maintenance of your company reports. Let's quickly switch to gINT and explore some of the library items. In gINT, we have 7 tabs on the top: Input, Output, Data Design, Report Design, Symbol Design, Drawings, and Utilities. 3 are directly related to the library: Report Designs, where all the reports are saved and designed; Symbol Design, for the symbol design and storage and maintenance; and the drawings, saved in the library. So if I go to the report design, as you can see, we have 9 types of different reports we can create in gINT, and they're all saved in the library. So again, it's highly recommended to have a single library company-wide so everybody uses the same reports. Symbol design, so we can have different symbols designed in the library saved and managed in there for material symbology, sample symbology, well symbology, general symbology, tiles, hatches, and so forth. And drawings, this is where you would usually put some generic drawings like title blocks or track codes to show you the location of the project, data template, report, and so forth. Back to the slide and question. So as for the data template or GDT file, it stores the structure and input formatting of project databases. You use the data template to create new projects through the cloning process, and reports use them to display database structure. In simpler words, a data template is a bucket, a container with different components, similar to MicroStation seed file used for new design file, or Microsoft Excel template used for a new worksheet or workbook. gINT template GDT is used to start a new project, GPJ. And finally, a project file or GPJ file is used for actual data input. It is a container with a content. As opposed to the container shown in the picture holding a soil, our container holds a soil properties. So the project file is cloned from data template, it's named and then populated with data. And here are some related questions to data template, project, and library. So how do I start new project? Let's go to gINT again. So you can start a new project by going to the File menu, the New Project, Clone Data Template. This will open Clone From dialog box. So you will see a list of GDT files. Ideally, your company should have one GDT file. You select appropriate data template, click Open. That is going to give you a new dialog box called New Project Name. So now you have to name your project. Then why should I use a data template instead of just cloning an existing project? The answer is, in well-maintained gINT environment, a data template is unique for the entire company, And ideally, a gINT administrator or a gINT manager would maintain the data template so all the projects across the entire company are consistent. If you are cloning existing project to start a new one, somebody might have added a new field in existing project, so now you start losing on consistency, and down the road that can cause a lot of grief. So that's related to the next question, adding a new field in input mode in relation to data template and existing project. So although you can add a new field in existing project, this is not recommended unless it's very specific to that project. But if the field is more generic, it should be added to a data template, again, to maintain the consistency for all the projects company-wide. And then, how do I check I'm using the correct library? So let's switch to gINT again. You can check what library you're using in the title bar of gINT window. So in the title bar, you can see the current project that you're working on, as well as the current library that you're working on. Again, it's highly recommended that you use one library company-wide. And then one of the questions is, are there any best practices with respect to report templates? Well, there are many, but they may differ from company to company. A few generic rules are use column entities instead of single entities unless really necessary. And then the more you know about gINT and its functionality, your reports may grow in complexity, but the maintenance of them may become simpler and simpler. A couple more library-related questions. When should I use library table lookup instead of lookup list? Well, lookup lists are more simple, and the other advantage of them is they maintain the list order. So majority of lists in gINT is automatically sorted, while the lookup list allows arbitrary order. As for the library tables, you can add new records in the input, which you cannot with lookup lists. You can store additional fields, object attributes, which can be reported. And AGS ABBR table automatic filling requires library table lookup with a field called description. And finally, why should I use user system data items? Well, there is a simple answer to it, and that's because to simplify management and reusability of report expressions. So if you ever design any of the reports, you know that you can write expressions. On the slide, you can see a long expression on the right-hand side, which is saved in the user system data on the left-hand side, so it looks much simpler. It's stored on the central location in the library, and it can be easily reused in other reports. Next question, what is the difference between the different override options when importing? So why is that question important? Is simple because in geotechnical and geoenvironmental engineering, there is a lot of data importing, exporting, manipulation, re-importing, re-exporting, and pushing from one location to another location, and so forth. Some examples are surveying data. While geotechnical engineer may be collecting subsurface information like soil data and properties, a surveying group could be collecting locations. It is likely that surveying group will collect data in a separate file, maybe a text file or Excel file, and geotechnical or geoenvironmental engineer would like to include that locations in gINT file, so they have everything on one location centralized. The other example of importing data would be lab data. It's not that uncommon that some geotechnical companies have lab work outsourced to a professional laboratories, and then professional laboratories send them their findings and lab results in digital form, most likely in Excel format or in text file format and so forth. So in that scenario, there will be a lot of data circulation between the geotechnical company and the lab. And again, geotechnical or geoenvironmental engineers would like to include that data in gINT and centralize it so everybody can reach it across the company, especially in the enterprise environment in multidiscipline company, and many other engineers may reuse the data for their own purposes and workflows. So going back to the override option field as shown in the dialog box on the slide, controls how the program will deal with data. that are in both the current database and the external file. So the current database, so we can call target file, and the external file we can call source file. So data import is used to importing data from different file formats and different operations. Some of them are importing data from Excel file. This is a very common question, as well as from the text file. For example, some CPT data, cone penetration test data, is often collected in a text format, so that can be also imported in GINT, and we strongly suggest to do that. Importing from other databases, if two companies that are GINT users exchange the data, for example, so they both save their data in databases, that can be also imported from one database to another. Then batch import from multiple databases. Example would be if one company wants to consolidate multiple projects in one project, especially in Professional Plus, then they can do a batch import their legacy databases. Then importing data from AGS file. AGS file is a special format for a geotechnical and geoenvironmental data exchange. And then importing data from log plot files. So some clients may have used log plot in the past or received log plot files from other companies, and if they use currently GINT, again they want to consolidate and centralize everything in GINT, so that can be done with these procedures. So what are the override options? As again shown on the slide here in the dialog box: never option, then empty fields, then named fields, then records and data sets. So in essence, again, like we are talking about source and target files, data coming in from source file into a target file, and it's all about what data wins. So who wins, source versus target? And options that are listed in this dialog box are from least to the most destructive to the existing data. So for example, never will do pretty much nothing to the data, while data sets will do a serious change, and we will explain that in more detail. It's important to say that all options affect existing records, meaning when there is data to overwrite, that's the name override options. Otherwise, data is appended, so these override options only affect existing records. And then the other thing to point out is that never option, records option, and datasets option apply to records or rows in database. And then empty fields and named fields options applied to fields or columns. One thing we are proud of that these options are unique to GINT. And also there is no option for clearing all original data. It's only subsets get overwritten. Okay, let's explore one by one option. It is a little bit confusing. It's important matter. You deal with data, with your databases, and incoming data. You want to double, triple, quadruple check that you're not making any damage to existing data because you invested a lot of time and money in it, and you want to keep it safe. So let's start with the override option, never. That's the least destructive option. This description is copied from the help file. So adds records whose keys do not exist in the current database. Existing records will not be changed in any way. All options share this behavior for new records. Okay, now let's actually say that in plain English and then in example, because some of these terms are database centric, so database people can easily figure out what it means, but just regular folks that do their normal engineering work every day are not familiar with them, so let's explain that in simpler wording. So only in this example we have a source file, which is an Excel file, and then we have a target file, which is a GINT file, and we're applying never option. So we have like 4 boreholes, and we are looking at a point table in both files, and we have a point table shown on the left hand side in the source file. It has 4 locations, B1 through B3 and TP1, And in the target file, we have like B1 and B2 only. So basically, there are two existing records, B1 and B2, and never options guarantees that nothing will be overwritten. So only new records B3 and TP1 will be appended, and existing records like B1 and B2 will never be overwritten. So if I ran the import, what I would be seeing, B3 and TP1 coming in, and as you can see, after the import B3 and TP1, two new rows are appended, but B1 and B2 left intact. On to the next option is override options empty fields. Again, copy and paste it here from the help file, writes data from the source only if the corresponding field or column in the target is empty. Okay, let's see that in an example. Again, we have a source file and a target file. And in the source file, we have four locations, B1 through B3 and test bit 1. In the target file, we have three locations, B1 to B3. Now, again, to put this in plain English, only empty fields, in this very case, elevation, will be populated, and existing values in non-empty fields will remain intact. And new records will be appended. Like for example, TP1 it doesn't exist in the target file, therefore it's going to be appended. And you can also notice east column. I entered dummy values in east column in the target file 1 to 3, and once we run the import, we can notice that surface elevation is now populated with values from the source file, and the east column remained the same because it already existed. But you can also see like that test bit 1, a new record, entire new record actually got appended, and now it's visible in the target file. Okay, on to the next option, it's named fields. So again, like copy and paste from the help file, it writes data from a field named in the source wherever a matching field exists in the target, overriding any contents of the target field. Note that if a field is a blank in the source, it will overwrite any contents in the target field and leave it blank. Okay, let's explore that a little bit more. And again, in simpler words, only properly spelled fields will be overwritten. Otherwise, the values remain intact. And new records again will be appended, like again example with test bit 1. So let's observe the source. First of all, I want to draw your attention to, let's say, north. It's deliberately misspelled in the source file, H missing, and also entered dummy values like 100, 200, 300. Let's observe the east column. So east column exists, it's properly spelled, and the right values in the source file as collected in the field by surveyors. And then let's also observe elevation column in the source file named elevation, and in the target file displayed as surface elevation but still named elevation, so it actually matches. Now notice that elevation column in source file is empty. And then finally, we have a contractor field in the source file that doesn't have a title. After we perform the import, here's what is going to happen. So observe the target north column hasn't been overwritten because basically it doesn't exist in the target file in the database, so nothing to be overwritten. East values got overwritten. The existing values for elevations got replaced with the empty string values from the source file. Finally, observe the contractor, and it's ignored because it's misspelled. If you have a new record as test bit 1, that gets appended. And then let's observe the records option. It can copy and paste it from help file, erases each target record matched by a source record, same key in database terminology, and writes the data from the source. Any records in the target that do not have corresponding records in the source will not be affected by the import. So this applies to records or rows, and let's see an example again. In this very case, in simpler words, the target records or rows will be overwritten. Other records will remain intact. Again, new records will be appended. So in this case, we are observing a sample table in both source and target files. And in the source file, in Excel file, we can see point ID is being that we are considering is B1, borehole 1. And observe depth. Here, the depth is a key for the database. It has to be unique. And we have depths in the source file of at 5 and at 45. So in the target file, we have depth at 5, but we do not have the depth at 45. So the field at 45, the row or record at 45, it's a new one, and it's going to be basically appended. But the record at depth 5 it does exist. And if you observe a type column in the source file, is called SPT, standard penetration test, and in the target file is labeled as GB or grab, for example. After the import, you can observe is that the record at depth 5 got overwritten. Observe the type column or type field. In the target file now we have SPT, and at the very bottom we also see new record at depth 45, and that's been appended entirely to target file. And finally, let's observe the last option, override options datasets. This does not wipe out all the data in the database. It replaces entire sets of data. The resulting data set will contain only data from the source file. A data set is defined by the key set of the parent table. For example, in a table with a point ID depth key set, a data set is all records with a particular point ID value, while for a point ID depth reading table, a data set is all records that share a point ID and depth. If a data set in the target file is not included in the source file, the data will be left unchanged. Okay, let's try again to simplify that in plain English, just to understand what data set is. So another way to describe a data set, it's the data you see when you enter a table in input. You show one data set at a time. So when you go to input mode of gINT, click on any table. This is basically a data set, what you see in the table. So let's observe that in an example again, and in some simpler words, entire target data set or rows will be deleted and replaced with the source data set. So on the left hand side we have an Excel file coming in as a source. We can see only 2 rows in this file. Again, we are observing a sample table in this case, and then in the target file for B1 borehole we have multiple entries for sample data. Now this option data set, what we'll do, will take all the existing data set related to B1 for sample table, remove it completely, replace it with the source data set, which in this case is only 2 rows. So after the import, what will happen, again, as you can see in the target file, only these 2 rows now exist in the sample table in the target file, and this is design behavior. And there is also data sets that I used in this example available per request. So basically you can experiment on your own and double check what I just showed you. And then there is a set of questions related to gINT rules, like for example, what gINT rules are, how can I get started with gINT rules, what can I do with gINT rules, how do I create fields that are calculated based on the content of other fields in the record, and so forth. In general, gINT rules are advanced environment in gINT. They are application programming interface or API, and you can do advanced customization and automation with gINT rules. This year we have a lecture named Using gINT Rules, coded GT4LT1, and this lecture provides you with more details on how to start with gINT rules and what you can do with them. Also, this lecture, as all other lectures, will be recorded and supplied to you after B in form of DVD or CD. And then we had a set of questions related to enterprise environment, like for example, how does gINT interact with ProjectWise? What version of Microsoft SQL Server should I use with gINT Pro Plus? To answer that immediately, currently we support version 2005 and 2008. And then, do we run on tablets or iPad? So as for the tablet, gINT is not certified to run on the tablet, but we have users that successfully run gINT on Microsoft-based tablet PCs. As for the iPad, gINT is currently not supported on iPad, but there are circumstances like virtualization and managing gINT in cloud would actually allow you to use gINT under such circumstances, even on iPad. Again, this year we also have a Managing gINT in the Enterprise Environment lecture, coded GT3LT2. And this lecture covers questions related to enterprise environment in greater details. Again, as all other lectures, this one will be recorded and supplied to you in form of CD or DVD. And then fairly frequently we have a set of questions related to AGS. What is AGS? Does gINT support AGS? How do we produce AGS data? And so forth. So the AGS stands for the Association of Geotechnical and Geoenvironmental Specialists, or AGS. And it's a non-profit making trade association established to improve the profile and quality of geotechnical and geoenvironmental engineering. AGS is also international standard for exchange of the geotechnical and geoenvironmental data, and it is very frequently used and even mandatory in some parts of the world. You can find more about AGS at www.ags.org.uk.